Hello my dear students of class 12. Today we will be continuing with the chapter the organic compounds containing nitrogen, and in particular today we are going to discuss about aniline. So the formula for aniline is 6H5NH2 as you can see on the blackboard, and you can also denote it with the benzene ring, and over that one of the position of benzene ring is substituted with NH2 group. So under aniline we are going to discuss about laboratory preparation of aniline. Laboratory preparation of aniline. So in the lab, it is prepared by the reduction of nitrobenzene. So in the lab, how it is prepared? It is prepared from nitrobenzene and it has to be reduced. Okay. So you have, as you know, the formula for the chemical structure of nitrobenzene is NO2 in the benzene ring. So whenever it is reduced in presence of tin and HCl, this is the reducing condition, you have to remember. This is reducing condition. Nascent hydrogens will be produced. Okay? And as a result of which you will be getting aniline after the reaction. So you will be getting aniline after the reaction. Here 6 atoms of nascent hydrogen is required for this reduction, and the byproduct obtained is H2O. Okay, 3 molecules, 2 molecules of H2O will be produced. So you have to remember, this is the laboratory preparation of aniline, and it is from nitrobenzene. Now let's discuss about the chemical properties of aniline. Chemical properties. So, under the chemical properties, we are going to discuss about the reaction of aniline. As you know, aniline is basic in nature. So, whenever it reacts with base, we get salt. So, first we are going to discuss about reaction with acids. Okay. So aniline can be written as C6H5NH2. So whenever it reacts with say HCl, hydrochloric acid, a salt will be formed, and the salt is C6H5NH2 dot HCl. So this is salt produced, and the name of the salt is anilium chloride. So its name is anilium chloride. Similarly, whenever it reacts with say sulfuric acid, C6H5NH2, reacting with sulfuric acid, we get again another salt, C6H5NH3, and you have HSO4. So this is positive, this is negative, and this is the salt, and the name of the salt is anilinium sulfate. So its name is anilinium sulfate. This is a simple reaction where whenever this basic property showing aniline reacts with acid, it forms salt. So let's discuss about the next chemical property, that is alkyl acid. Alkyl acid. So whenever this aniline reacts with say alkyl chloride or iodide, what will happen? This contains lone pair, this will be attached to this will be out. So you will be getting C6H5 and HCl2. Okay, and here one hydrogen from here and one HI will be removed. Similarly, if it further reacts with, since it has replaceable hydrogen, again it reacts with alkyl iodide, that is CH3I, and again you will be getting C6H5 And now this hydrogen will be replaced with CH3 group. So it will be having CH2 twice, one and one more, CH3 twice, minus H. Further, this reaction takes place since nitrogen has lone pair. Again, it reacts with CH3I to give you C6H5 and CH3. Now, whole thrice. 2 positive positive present, one more will be added here. So it will be 3 plus this will be positive. And this iodide now will come and stay here to it as negative sign. Okay, so we start with the primary amine. This is first degree amine. We got second degree amine here. This is third degree amine. And finally we got quaternary amine. Quaternary aniline in this case. Okay, so let's discuss about simple. All the hydrogens will be replaced by alkyl group and one more. Since it contains lone pair, this lone pair will also react with alkyl chloride or iodide to give you quaternary salt. You have to remember this reaction. Now let's discuss about acetylation. 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 So aniline, it reacts with either acetyl chloride or acetic anhydride to form these anilides. Okay, anilides. So you have to remember this reaction as well. So you have, say, aniline, NH2. So whenever it reacts with CH3, COCl, what happens? You have NH, one of the hydrogen will be replaced with CO, CH3 group, and the byproduct that you obtain is as Cl. Okay, so this compound is known as what? It is known as anilides. Now let's discuss about benzylation. Benzylation. Benzylation is similar to acetylation. It's just the difference is in this CH3 group. Instead of CH3 group, you'll be having benzene. Okay, so the reaction will be almost similar. So we have aniline and NH2. Now, instead of CH2, you will be having benzene ring, that is C6H5 COCl. The reaction takes place in similar manner. This CO will be bonded with nitrogen, and you will be getting this compound. You have NH, now CO, C6H5, and your byproduct will be HCl. Okay, so you have to remember this reaction, and this reaction is also known as Schochen-Baumann reaction. So you can refer to the book. You can refer to your textbook. It's the name of this reaction is Schochen-Baumann reaction. Now you know this aniline is primary amine, and in our previous video we had discussed about carbylamine reaction. And this aniline, since it's a primary amine, it undergoes carbylamine reaction. So carbylamine reaction is only given by primary amine. You have to remember this. Now we are going to discuss about carbylamine reaction. Carbylamine reaction. So in carbylamine reaction, primary amine, and in particular here we are discussing about aniline. Aniline reacts with chloroform, CH3 in presence of KOH, okay, to give you phenyl isocyanate. So you will be getting phenyl isocyanate and 111C. And your byproducts are KCl and water. So you will be getting these byproducts, and balanced equation is 3 molecules of KOH induced and 3 moles of KCl and 3 moles of water will be produced. This is phenyl isocyanide, and it has a very characteristic offensive smell, that is a very unpleasant smell. So from the smell itself you can make out this isocyanide compound, and this is given by only first degree amine. It is given by only first degree amine. So we have to remember this. Now let's discuss about the reaction of aniline, and under which we are going to discuss about electrophilic substitution reaction. And this part is very important. Okay, you have to remember this. Electrophilic substitution reaction. So whenever we discuss about electrophilic substitution reaction in aromatic compounds, you must remember it, you must have studied that whenever there is electron donating group, then you get ortho and para directed product, and whenever there is electron withdrawing group, you get meta substituted product. But in case of aniline, you can see it here, the structure of aniline, NH2. So this NH2 is electron donating group, so it is going to activate ortho and para position. So whenever an electron comes, it comes at ortho and para position. But here there is some unique nature of NH2 whenever it is present in benzene ring. So you have to remember this. So aniline, this NH2 group, whenever it is present in benzene ring, it activates the ring to such an extent that instead of just getting mono substituted product, you get this ortho and para substituted product. That means you have 2, 4, 6 tri substituted product. For example, so whenever aniline reacts with, say, any electrophile, usually this reaction takes place, okay, usually positive. Then what happens? You get the product where you have this electrophile groups coming at ortho as well as para position in the same compound. So we do not get the desired product. So how can we obtain the desired product, like only ortho substituted product or para substituted product? So that we have to remember. Okay. So I told you just now, aniline is very reactive. So usually whenever it reacts with electrophile, ortho as well as para substituted product is formed. So let's take one particular example. Say you have NH2. Whenever you treat with, say, bromine, it doesn't even require any catalyst. The reaction takes place such that this bromine, you don't get just this ortho substituted this product. You get ortho substituted in both the ortho position as well as para position. So what can we do to get only either ortho substituted product or para substituted product? So in order to obtain only ortho substituted product or para substituted product, what we have to do is we have to decrease this electron donating capacity of what? NH2. So for that we should carry out acetylation. So you have to remember this, okay? So if you want to get only either ortho substituted product or para substituted product, your first work is to convert it into, you have to react it with the acetyl chloride or acetic anhydride and convert it into acetylenide. So at first what we do is this benzene ring is treated with, say, CH3, CO, Cl. So now the product that you obtain here is NH, CO, CH3. Now whenever this CO group comes to this N nitrogen of benzene, this aniline, what will happen? This lone pair will be pulled by C double bond O, and as a result, this benzene ring will be deactivated. Now after this process is known as what? Protection also. Okay, this process is also known as protection. Now after this you have to carry out all those reactions like halogenation. Now at first what you are doing? You are converting it into acetinolite, and after this you are going to carry out, say, NHCOCH3. Now if you carry out halogenation, now you will be getting NHCOCH3, either ortho-substituted product or para-substituted product, COCH3. And here you will be getting either ortho only substituted product or para-substituted product. So now again we want to get back this NH2 group. Okay, we do not want this entire group. Instead of this, we want this NH2 group. So in order to obtain that, you just have to just do the hydrolysis. Okay, so once you do the hydrolysis, you get the desired product. That is, NH2 group will come back, and here you will be getting bromine, ortho substituted, and para substituted aniline. So the most important step here is this part. If you want to get mono substituted product, at first this has to be protected over here, okay? And after that you have to carry out the halogenation or nitration or sulfonation. So now let's discuss about nitration then. Below concentrated nitric acid is very strong oxidizing agent. So here also, at first what you have to do, you have to convert this aniline into this group. After that one you have to carry out nitration. So nitration. You have NHCOCH3. So whenever you treat with concentrated HNO3 and concentrated sulfuric acid, you get either ortho-substituted product, NHCOCH3, ortho-substituted, NO2 coming in ortho position, and the next one you have NO2 group coming at para position. So I told you how to get back this NH2 group here. You just have to do hydrolysis. Acidic hydrolysis. So once you do it, you get the desired product. That is, the NH2 group will come back. You will be getting NO2 group at ortho position, and this NH2 group is back, and at para position you have NO2 group. So this is the process how you carry out nitration if you want to obtain either ortho-substituted product or para-substituted product. Now sulfonation. Now let's discuss about sulfonation. Now in case of sulfonation, this protection is not required because concentrated sulfuric acid is not that strong oxidizing agent. Okay, so let's discuss about sulfonation. Now for sulfonation, as I told you, this protection is not required. You can carry out sulfonation directly with aniline because, as I told you, this concentrated sulfuric acid is not strong oxidizing agent. Now we are going to discuss about sulfonation. So whenever aniline reacts with concentrated sulfuric acid, what will happen at first? We get a compound, intermediate compound, NH3, HSO4 minus, this is positive, this is negative, one hydrogen is taken by nitrogen, so NH2, so one hydrogen is less with it. After this, you just hit it, okay, hit it, rearrangement will take place, rearrangement, and as a result, and you have to be very careful here, you obtain, you have NH2, and you obtain para-substituted product, that is SO3H. So you get para-amino sulfonic acid as the only product. You don't get ortho-substituted product. This part you have to remember. Okay, this is, you can carry it carry sulfonylurea directly with aniline. You don't have to convert it into this acetylenite. And one more and most important point that you have to remember is you don't get all the substituted product here. The major product that you obtain here is para-substituted product. Thank you.